Hi guys, this is the first video about trying to put everything together, everything that we've done so far, the modules and the solvers, to put everything together to create an actual character. At the end, it's still going to be quite a basic puppet to animate, but we should be able to have a biped at the end that covers all the basics, and the principles of control rig. There is still stuff that is missing. Even if we touch the arm module, spine module, leg module, head module, and eye module, there is still stuff in between that needs to be discussed. And this relates to how these modules are connected together. How can we create spaces to perform different orientation and translation, and other stuff. Before we jump into Unreal, this is not going to be a video in Unreal. I just want to introduce you to this character. I'm calling this character SkeleTron, and this is how I've built it and why I've built it. So first of all, I purchased this model here on TurboSquid, and the reason why I purchased this, it's because I wanted to have a very basic skeleton that identifies just the volumes but with enough detail. Not to lose any information that is related to the skeleton. So this is the model I've purchased, and after that what I've done is I went through a little bit of remodeling in order to accommodate certain things that I wanted to have, for example the eyes, but also I wanted to have a slightly different topology, etc, etc. So I retopologized it, but that was the model I started from. Then I just simply painted a texture just to make it look a little bit prettier. But more important than the geometry per se, this skeleton does have a lot of thought process behind, and I'm gonna try to explain it. So you probably already have noticed how much I rely on anatomy, and I still think it's a very good idea to have a strong knowledge in anatomy, especially if you're a rigger. So the skeleton is always, the base for everything that is, the skeleton in the end is what drives what the muscles are attached from. So it's a really good base to start analyzing how the kinematics of and motion of the body happens, what happens under the hood. So let's go through a little bit of the geometry first. So this geometry informs me in a really nice and stylized way where the pivots are. I place these pivots paying really close attention to how the bones revolves around themselves. So this is just to lay down a solid foundation for what I want to do in Control Rig in Unreal. Another thing that this explores has a lot of joints when it comes to the rib cage, and as we saw in the module of the spine, this is not strictly necessary, but I wanted to give this guy a little bit of non-realistic deformation behind the back, which can always be manipulated to look realistic. So this is another thing that it's a clear indication of where the module should connect and disconnect, meaning that around here there is the base of the rib cage, roughly around there. So that's definitely where the one pivot should be for our controls. And then of course I went through and added the pivot. So in here, without having the complexity, the geometrical complexity that describes the skeleton, with simple shapes we can understand the kind of motion that we're looking for. So in this case, it's really clear that I'm trying to revolve around a specific pivot. And then I added the eyes, so we are able to use the eyes module we spoke last time. And then there is a very simple jaw. So this is it from a geometrical perspective. You can see how the knee actually revolves around that kind of pivot. And same goes for the ankle bone, etc. So in this is everything about the geometry. Now, from a geometry point of view, I thought it was necessary. The texture is just a bonus to make it look pretty. But a lot happened on a skeleton, from a skeleton point of view. And first of all, I started using a little bit more, anatomically correct naming. You may guess why. And the other thing I've done, if I select all of these, and I say display, transform display, local orientation axis, I basically changed completely the orientation compared to the one we've used so far. And there are multiple reasons for this. The first one, as you may have seen in other videos, I'm constantly trying to make the solvers and the modules robust enough to handle every possible kind of joint orientation. If you're coming from Blender, 3ds Max, or you may have a software that has a different orientation of bones altogether. You may have a software that only uses X along the axis. It's very common in setups to see X along the axis. In this case, I made Y along the axis. And this is with the clear intent to basically have a clear difference between everything that I've been using so far that was using X, so I can check and double check and triple check that the solvers are able to handle a different orientation. But the other reason why I've done that, it has to do with the fact that I want to start introducing some more anatomical things, and the way I am describing the orientation of these joints and the kind of process that I used when I get asked to rig a creature that I'm not familiar with. So let me introduce you to the concept of axial skeleton and appendicular skeleton. So in my endless quest to try and define and find rules to define certain things based on what is given to me, one of the things that you always ask is is what is up, what is along, what is the width, what is the size of the bone, what is the width of the skull, is this the length of the bone, or is this the height of the bone? So the closest thing I could find was the way bones gets classified when actual scientists do classify bones. And while I was researching that a while back, I discovered this kind of naming convention that I found really useful. So I'm going to try to describe in my own words. The axial skeleton, you can see it's highlighted here in blue, is basically, it defines the axis for this specific creature. In this case is a human. So if we look at here, I am defining the axis from this skeleton with the Y up. The reason why I picked Y up, it's one, because it's different from X along the X axis that I'm used to make sure that the modular are working in any scenario. And the second reason is because it's the way Maya aligns the bones in world space. In Maya, Y is always up in world space. So there are two main reasons. That's why I picked Y. It's not this axis, the fact that the Y it's up is not strictly necessary. I'm just giving you the reason why I made this choice. So I have this. So this axial skeleton is at the center, and it's I'm using it as a reference point to drive all the orientation of everything else, which happens to be called appendicular skeleton. So if in my axial skeleton I'm defining that the axis where the skeleton, where the joints are oriented, it's in this case Y, then I have a reference point for everything that is defined appendicular. So you can see that the appendicular skeleton, and this is true not just for humans, by the way, this is true for any, you can do this in comparative anatomy. So if you have a limb attached to an axial skeleton, there is an insertion point, and then there is an insertion point, and then there is an end point. So the limb, or the part that is part of the appendicular skeleton, emanates from a point and goes along till the very extremities of this appendicular skeleton, in this case, the right arm. So it starts from here and it goes all the way down here, which means if I'm defining the point of reference with the y up, let's look into Maya. In here I have y up, in here I have y along the way. And the way I'm gonna try to read it to you, if I consider this module on its own, this is how it would be aligned to the world, with y up along the module, along the appendicular skeleton, the same way the spine flows. And the way so if you can consider these portions of skeleton, one being an appendix of another one, so where this is the insertion point. So what I would do is move the insertion point here and then orient it the way I want it. So I know this sounds a little bit crazy, what I'm doing here, and a little bit weird, but this is just trying to define a set of ground rules in order to define how an axis can be chosen. I hope that makes sense. And if you notice it, and we discussed this a little bit when we were talking about the flexion and extension of the spine compared to the pelvis, that the fact that when the spine moves forward, the pelvis rotate forward, so we can keep the values. And the reason is actually anatomically explained by the fact that this, the leg, is another appendicular skeleton, is another part of the appendicular skeleton, which means if I pick the origin, or the insertion point, move it to the origin, and then I orient the y along the structure till the very end, you can see that the y is constantly oriented along the way, which means like if I put everything back to 0, this is kind of the object that we're manipulating. So we get that. Then the only thing I need to do is take this object here, move it into the insertion point, and orient it the way I want it in order to match whatever I'm trying to do. So you can all of this to say that, let me undo that for a minute. All of this to say that yes, the legs are pointing downwards. The legs are pointing downwards. Now, why is this y pointing up? Is because in this case all the axes are flipped. This has nothing to do with appendicular skeleton or anything. This is just to get this behavior here. So both values mean the same thing. It's the same idea that we're using. So I simply flip the axis. But conceptually it's y going along the axis. And this is to achieve this kind of motion, behavioral motion basically. So when I rotate both joints, I can get this motion instantly. And every time the animator takes this control and moves down, this control will mean the same thing, meaning I'm taking the arm from a T position closer to the body. It will be a positive value, and the same positive value will appear here, and the positive value will still mean getting closer to the body. Okay, so this is the reasoning behind this joint orientation. I hope that makes sense. So what else there is to say? Oh yeah, so let me go back to this for a minute. So if you have a look at the axial skeleton, it does not include the clavicles or the shoulder blade. And this is going to be reflected by our modules. Okay, so when we in our previous example, specifically for the arm module, we didn't took into consideration the clavicle. The arm module starts directly from the shoulder, from the upper arm bone here. Okay, we didn't talk about the shoulder blade, and we didn't talk about the clavicle. Now, there is a many way of thinking this. People are saying, the clavicle should be part of the arm module, or the clavicle should be part of the spine module. But in my case, I always want to have the clavicle embedded in the arm module. The reason why I did not implement it is because in order to produce the behavior of the clavicle, I wanted to properly introduce the concept of spaces, which I have used, but I haven't touched them yet. And this all fits together in the way we are going to, make all of this work and see how the switching between spaces can be used in order to give animator more flexibility while animating. Same goes for the shoulder blade. The shoulder blade is quite a complex behavior because you would assume that it lies around the rib cage, which is absolutely true. The problem is that the rib cage is not a spherical surface, so you cannot find a perfect pivot. It's a combination of rotation and translation. So in traditional rigging, you would create like a path to have this rib cage follow. So the motion of the rib cage and the clavicle is something we will have to include into the arm module. And another reason for why I think that's the case, I'm falling back to anatomy. Part of the appendicular skeleton, it's the clavicle with the arm. Has nothing to do with the axial skeleton. So all of this to say that we will start seeing how all of this fits together in Unreal. I started doing some stuff here, but we're not going to look at it. So just a preview. So all of these modules working together in conjunction to create something that is, not only anatomical correct, but also fun to animate. We will see how all these modules now are working separately. There is no connection between one another. And we're going to see how to connect the modules together, introducing the concept of plugs, inputs and outputs of a module, and stuff like that. So I hope this makes sense. It was a bit of a weird video, but I still think it's, worth discussing. Bye bye.